A histogram is basically a graph that simply tells us how much darkness and brightness we have in this photo and how they are distributed. Now let's read the graph itself. This horizontal line at the bottom of the histogram is completely black on the left, and as we move to the right, the image gets brighter, until it reaches absolute white. Meaning the left side is black, followed by shadows, midtones in the middle, highlights on the right, and at the very end there is white. Those columns going upwards are just showing how many pixels exist in that specific light range. See, when I use a completely white background, its histogram moves entirely to the right of the graph. Now, if I add a black section to the image, as the black area increases, the number of dark pixels grows. And naturally, the column on the left side of the histogram starts to rise. The same thing happens with gray. When I add a middle gray, it immediately shows its effect in the histogram, and a bump forms in the middle of the graph. Every photo we take is a combination of different lights. The histogram divides this entire image into 256 brightness levels. Each of these columns represents one of these 256 light levels. And it's just saying how many pixels exist at that brightness level. Wherever the graph is taller, it means there are more pixels with that level of brightness in the photo. A very important point here is that the histogram doesn't show the location of the pixels. It doesn't say where the darkness is in the photo or if that whiteness is on your subject's face or in the background. Two photos might be completely different, yet their histograms could be nearly identical.
Another interesting point that's often overlooked is that the histogram is not the image's memory. What does that mean? It means if you change your framing even slightly, or if the subject moves just one step, the histogram will change immediately. Not because the scene's lighting changed, but because the pixel ratio has changed. That's why two photos with the same lighting and settings can have completely different histograms. Sometimes, by changing the framing, you can correct the exposure without even changing the aperture, shutter, or ISO. So next time the histogram looks strange, check the framing for a moment before you change the settings. Maybe it's not a lighting issue, it's the ratio of elements within the frame.
Now the question arises, which is the correct histogram? The answer is that there is no single correct histogram. The histogram must align with the concept of your photo. For example, in low-key photos, it's natural for the histogram to lean left, and for high-key photos, it naturally shifts more to the right. On the right, a soft, gentle portrait usually focuses on the midtones. Another very important point is that a centered histogram doesn't necessarily mean the exposure is correct. This is one of the biggest misconceptions. Correct exposure means that what you intended to show has been captured with the right details. Let me add a professional tip. The histogram you see in the camera, especially when shooting in RAW, isn't exactly your sensor's raw data. It's based on a preview that has styles and color profiles applied to it. That's why you sometimes think your highlights are blown out, but they're still recoverable in Lightroom. Now we need to understand how light and color are defined in the digital world. In the digital world, almost all images are created based on the RGB color model. That is red, green, and blue. Meaning every color you see in a photo is actually a combination of these three color channels. Now here's the important part. Each of these three color channels can record light intensity at different levels. This light intensity is stored numerically. In a standard system, 8-bit, each channel has 256 levels, which is actually 2 to the power of 8, meaning 256 different levels. Now you might wonder, where does this number 2 even come from? The answer is quite simple. Because computers, cameras, and sensors all work in a very basic language, and that language is zeros and ones, meaning the smallest unit of data, which has only 2 states. So this number 2 represents the number of possible states for each bit, 0 and 1. So when we say an image is 8-bit, it means each color channel has 2 to the power of 8 colors, which is 256. The number 0 means no light was recorded in this channel, and 255 is the maximum light this system can record. Color in a digital image starts with light, but it's stored using zeros and ones. Now, what do these numbers mean? 0 means that channel has no light. The number 255 means that channel is at its maximum brightness. For example, when all channels are 0, it becomes absolute black. And conversely, when all channels are 255, it's absolute white. Now let's get to grayscale, or what we call a black and white photo. First, let's clear up a misconception. A black and white photo means removing colors, not removing light information. In fact, in grayscale, we're still dealing with both numbers and light. When exactly does grayscale happen? When the values of all three RGB channels are equal. At that point, no color is created and only brightness remains. For instance, 3 zeros make absolute black, but 3 25s make a dark gray. Or 3 255s make absolute white, but 3 200s make a light gray. So in grayscale, we have 256 shades of gray. Now, how are colors created by the differences between these three channels? For example, suppose red is 255, green is 0, and blue is also 0. It becomes a pure red. Or red, 255, green 255, blue 0. It becomes yellow. So color is nothing but the ratio of light intensity between the three channels. We have a very important point here. When a camera or software creates a total number for light from these three RGB channels, we call it luminance or brightness. A histogram is a graph of the numbers that define light. Now let's move on to the next very important topic, the difference between 8-bit and 16-bit. In an 8-bit image, each RGB channel has 256 levels, meaning from 0 to 255. But in 16-bit images, each channel has 65,536 levels, meaning from 0 to 65,535. The numbers become much larger, but what's important is that the distance between tones becomes much smoother and more precise. Imagine the difference like this. 8-bit is like building a gradient with relatively coarse steps, and 16-bit is like building that same gradient with very, very fine steps. That's why in 16-bit, banding is less, color correction is safer, and detail recovery is better. But an important point, a 16-bit histogram looks similar to an 8-bit one, but the data behind it is deeper. That's why in a raw file, the histogram says one thing, but in editing, you see there's still plenty of room for correction. And finally, let me add another subtle point. The histogram isn't as emotional as our eyes. It doesn't understand whether the subject is important or the background. All pixels have the same numerical value to it. That's why sometimes the histogram says your photo is dark, but our eyes say it's exactly as it should be. The histogram is the technical reality of the photo, not our emotional perception of it. Professional work starts right here, knowing when to listen to the histogram and when to trust your own eyes. Every time you change the exposure, you're actually shifting the distribution of the 256 light levels, not just making the photo brighter or darker.